Those who have seen the film The Day After Tomorrow should have a deep impression of the ice and snow world caused by the climate change in the movie. According to the description in the film, one of the important reasons for this climate change is the stop of the Atlantic Meridional Overturning circulation. What is noteworthy is that a new study published in the journal Nature Communications shows that in the not-too-distant future, the Atlantic Meridional Overturning circulation may collapse, which inevitably raises concerns about whether the day after tomorrow of human beings will come in the real world. Let's talk about this topic. There are vast oceans on the Earth, so that the ocean area occupies about 71% of the entire Earth's surface. On the other hand, among natural objects, water has the largest heat capacity. With the absorption or release of large amounts of heat, the temperature of the oceans does not change much. Therefore, the oceans are often referred to as the big air conditioner that regulates the Earth's climate, because it can both cool down and heat up. The seawater flow in the oceans of the Earth is not chaotic. In many areas of the global ocean, seawater flows regularly to form ocean currents, large and small. Among them is an ultra-large-scale ocean circulation system called the thermohaline circulation. Simply put, the thermohaline circulation is a global ocean circulation system driven by density differences caused by the temperature and salinity of seawater. In fact, the Atlantic Meridional Overturning circulation is an important part of the thermohaline circulation. Its characteristics can be simply described as there is an ocean current in the upper layer of the Atlantic flowing northward from the equatorial region, consisting of warm and low-density seawater. This ocean current flows northward and gradually cools down. On this basis, with the continuous evaporation of water, the density of seawater also increases. Eventually, this ocean current sinks into the deep sea in the North Atlantic region and returns southward, forming a southward ocean current consisting of cold and high-density seawater. In this way, a giant circulation is formed in the Atlantic, with warm surface water flowing north, deep cold water flowing south and overturning at both ends. So this circulation is called the Atlantic Meridional Overturning circulation. In general, the Atlantic Meridional Overturning circulation can continuously transport heat from the equatorial region to high latitudes, making the equatorial region less hot and high latitudes less cold. Therefore, it has a huge impact on the climate of the northern hemisphere of the Earth, especially the Atlantic region and its surrounding areas. In previous studies, scientists have found that the Atlantic Meridional Overturning circulation is at its weakest level in nearly 1,000 to 1,600 years, and it also shows signs of continuing weakening. Scientists speculate that the likely cause of this phenomenon is global warming. This is because global warming leads to more melting of ice sheets and sea ice in polar regions, as well as increased precipitation in surrounding areas. For the Atlantic Meridional Overturning circulation, this means more freshwater inflow, which reduces the density of seawater. With the decrease in density, seawater in this area becomes less and less likely to sink, which will cause the Atlantic Meridional Overturning circulation to continue to weaken. It can be imagined that as this process continues, when it exceeds a certain tipping point, the Atlantic Meridional Overturning circulation will collapse. So when will this tipping point be exceeded? In fact, the aforementioned study aims to solve this problem. In the research, scientists used a statistical method to estimate the time when the Atlantic Meridional Overturning circulation will collapse. Simply put, this method is based on the assumption that when a system approaches a transition point, it will exhibit periodic oscillatory behavior. This oscillatory behavior can be described by a mathematical model and extracted from actual measurement data. By analyzing the parameters and characteristic values of this mathematical model, scientists can estimate the distance from the transition point of the system and predict when the transition point will occur. This study used 8 independent measured datasets dating back 150 years. The results show that according to current trends, the Atlantic Meridional Overturning circulation may collapse in the mid-21st century, 95% confidence interval between 2025 and 2095. So what effects will it produce if this really happens? Let's continue to see. According to the description in the sci-fi film The Day After Tomorrow, the collapse of the Atlantic Meridional Overturning circulation prevents effective heat exchange between high and low latitudes, causing cold and hot air to accumulate continuously. When it reaches a certain level, the cold and hot air begins to burst and expand, specifically manifested as cold air rushing towards the equator and hot air rushing towards the poles, thus forming several huge supercyclones globally. These supercyclones are very violent. An extremely low-pressure environment is formed at their centers, so that the cold air in the stratosphere is pulled down in a very short time. The air temperature in the stratosphere is usually minus tens of degrees Celsius. Therefore, when this cold air reaches the ground, the temperature on the surface will drop sharply and become frozen. As the ice and snow-covered areas expand on the Earth's surface, the overall albedo of the Earth will rise rapidly, causing more sunlight to be reflected back into outer space, and less heat will be received by the Earth from the sun. Thus, the Earth's surface cannot warm up and gradually enters an ice age. So will such a scene appear in the real world? In other words, will the day after tomorrow of human beings come? In fact, if the Atlantic Meridional overturning circulation really collapses, the consequences will not be as exaggerated as described in the day after tomorrow. Theoretically, even if the phenomena described in the day after tomorrow do occur, it is a slow and progressive process that takes hundreds or even thousands of years for the Earth to possibly enter the so-called ice age. However, if the Atlantic Meridional overturning circulation really collapses, the impact would still be quite significant. According to scientists' speculations, if this really happens, the possible impacts will include but not be limited to the following. 1. The average surface temperature of the North Atlantic will drop by 2 to 3 degrees C within 10 years, and the temperatures in Northern Europe, Western Europe, and the Eastern United States will also decrease significantly, especially in winter, with average temperatures dropping by 5–10 degrees C on the present basis. The sea level along the east coast of North America and the west coast of Europe will rise markedly. 3. The frequency and intensity of extreme weather events worldwide will increase to some extent. Especially storms along the Atlantic coast will increase dramatically. Precipitation in eastern North America and western Europe will increase by 10–20%, while annual precipitation in regions such as India, South America, and West Africa will decrease greatly. The Amazon rainforest, known as the lungs of the Earth, may face serious threats. Of course, this is just speculation. Scientists still cannot give accurate answers about what will happen in the future. That's all for today. Thank you for watching. Don't forget to like and follow my channel. See you next time.